Hi, this is Venkatesh Prabhu. The topic is about mathematical modeling in unicellular and multicellular organisms. Mathematical modeling in unicellular and multicellular organisms. First, let us see the mathematical model in unicellular organisms. Model in unicellular organism. In unicellular organisms, this organism a model, the cell is going to be divided either in terms of dx by dt or dn by dt. X is in terms of biomass, whereas n is in terms of number of cells. Both the x and the n obey the same pattern of growth and it is with respect to time. So this can be written as dx by dt is equal to mu x or Tn by dt equal to k into n. So this x and n, the number of cells or mass of cell, is going to be grown with respect to the initial number of biomass or initial number of cells which is going to be present in a system, which is going to obey first order kinetics. This first order kinetics, if we are then dx by dt is equal to mu x. When you are integrating this dx with the limit of x naught to x is equal to mu into dt 0 to t, and this x is going to become on the left hand side, that is 1 by x into dx by dt. So in this, how we can able to write is dx by x with the limit of x naught to x is equal to mu into 0 to t dt. When you are integrating this, 1 by x into dx can be written as ln x with the limit of x naught to x. Similarly, mu into this is going to be t minus 0. So when you are substituting the limit, this can be written as ln x by x naught is equal to mu t. Taking exponential on both sides, then this equation is going to form it as exponential of ln x by x naught is equal to E of mu t. So exponential unknown will be getting cancelled when x is equal to x naught e power mu t. This is in terms of biomass. The same thing in terms of n when you are substituting, replacing x in terms of n, this could be written as n is equal to n naught e power k into t. So this is the model for the growth of biomass or the growth of number of cells which is going to be in unicellular organisms. So in this unicellular organisms, the growth pattern is going to be like this. So this is called as lag phase. This is the exponential phase, or trophophase. This is called as stationary phase, or idiophase, and this phase is called as decline phase. Here, the axis is going to be with respect to time, the x-axis, and y-axis is either x or n. So here, in terms of lag phase, the model is dx by dt or dn by dt is equal to 0 because there is no changes in x or no changes in n. Hence, it is going to be dx by dt equal to 0. Whereas in exponential phase or log phase, the biomass is going to be x is equal to x naught e power mu t, or n is equal to n naught e power kt, where k or mu is going to be the rate of biomass which is going to be formed in the system. So let us come to the next one, stationary phase. This is here is also dx by dt or dn by dt is equal to 0. Since the line it is obeying zero order matrix, and this line is obeying first order kinetics, and this line is obeying again zero order kinetics. On the horizontal line is obeying the zero order kinetics. Whatever the line which is going to be inclined in a positive or negative, it is obeying first order kinetics positive, first order kinetics negative. So coming to this model, so here x or n with respect to time. So the model here it is going to be dx, it is x is equal to x naught e power minus kt, or n is equal to n naught e power minus kt. Here this minus sign denotes the decline in the growth of the cells or decline in the number of cells. Hence, hence the conclusion is biomass growth x is equal to x naught e power ut, or in terms of n it is going to be n naught e power kt. This is the growth of bacterial cells or unicellular organisms. So, which is obey first order kinetics. Coming to the multicellular model, the multicellular model, let us consider a flask which is going to have a fungal type of cells which is going to be grow. Cells which is not grow as a disclosed form, it is going to be formed the form of pellets, or it is going to be in the form of beads form. This bead is going to be increased from the small spore to the larger in the diameter it is going to form. Hence, the growth of the cell is not going to be in a binary fashion. It is going to be grow in the form of radial growth. That means a small sphere it is going to be form the form of rod. So the diameter of the sphere is going to be increased, or the radius of the sphere is going to be increased. Hence, there is a separate model for the growth of multicellular organism. Growth of multicellular organism. So, as I already mentioned that it is not going to be formed as a biomass or the number of cells. So this is not going to be formed. Hence, it is going to be grow in the form of increase in radius of the cells. So it could be written it as dr by dt is equal to some constant as kp. So when you are integrating this, you'll be getting a model for a filamentous organisms. Let us see that. So the model is dr by dt is equal to kp, where r is the radius of the filamentous organism is in the form of pellet, and this r is going to be changes with respect to time, and kp is a constant. So the volume of mass of the pellet would be written it as m. It is nothing but density into volume of the pellet. Density remains same, whereas volume can be written as for the sphere it is going to be 4 by 3 pi r cube. Hence, when the small radius is going to be increased, the mass of the cell could also be increased. Hence, this can be written as dm by dt is equal to rho into 4 by 3 pi 3 r square into dr by dt. So when the mass changes, the radius will also be to be changed. So it can be replaced like this. Hence, when you are substituting, replacing dr by dt in terms of dm by dt, then we can arrive the model for the multicellular organism. So, how we can write dr by dt is equal to kp, but dm by dt is equal to rho into 4 by 3 pi 3 r square into dr by dt. So 3 and 3 will get cancelled. dm by dt is equal to 4 pi rho 4 pi rho r square into dr by dt. And when you are replacing this, dm by dt is equal to kp 4 pi r square rho. But when you are replacing the r in terms of n, we need to rearrange m is equal to rho into 4 by 3 pi r cube. 4 by 3 pi r cube. So r cube is equal to 3m by 4 rho pi. That means r is equal to 3 by 4 pi rho whole power 1 by 3 into m power 1 by 3. We need to substitute in terms of r square. So r, when you are squaring, r square is equal to 3 by 4 pi rho whole power 2 by 3 m power 2 by 3. So when you are substituting this model, then dm by dt is equal to kp 4 pi 3 by 4 pi rho whole power 2 by 3 m power 2 by 3. Assume all these entire term as comma. Then when you are assuming the entire term as comma, then dm by dt is equal to gamma m power 2 by 3. On integrating this model, we will be arriving a model for a filamentous organisms. So rearrange this equation. dm by m over 2 by 3 is equal to gamma dt. Substituting the limit as m naught to m and 0 to t, integrating this, m power minus 2 by 3 plus 1 whole divided by minus 2 by 3 plus 1 with the limit of m naught to m is equal to gamma t minus 0. This is the after integrations. We are arriving the model. Further simplifying this model, m power minus 2 by 3 plus 1 whole divided by minus 2 by 3 plus 1 m naught to m is equal to m mod t. Then substituting 3 minus 2 by 3, so that is 1 by 3. Hence, m power 1 by 3 whole divided by 1 by 3, the limit of m naught to m is equal to m mod t. Further simplification, m power 1 by 3 minus m naught to 1 by 3 is equal to 1 by 3 mod t. So m power 1 by 3 is equal to m naught power 1 by 3 plus 1 by 3 mod t. M is equal to m naught power 1 by 3 plus 1 by 3 mod t whole power 3. So this is the final answer for the total mass of the cells in terms of filamentous organisms. So the final answer is m is equal to m naught. So this is the model. So this is the final model. M is equal to m naught power 1 by 3 plus 1 by 3 gamma t whole power 1 by 3. Just write here. Thank you.